Hey my dear warriors, welcome aboard to the Vedanthu JEE English channel, and this is your captain speaking. So this is the timetable that I have put up for the next 3 days. Please follow this. And we had an amazing launch. We had a very grand launch, not just of the teachers, but also of the amazing 3 series, namely Flash, then you have your Marathon, and also your PYQ. So remember, today you're watching the modern physics lecture, and in the night you have Nabamita ma'am's class on coordination D and F block. Tomorrow you have the mathematics class at 6 o'clock and a big marathon of PYQs of all the 3 subjects on Saturday. Please note these timings, make a note of this timetable. Nice to see all of you on the channel. Hello Deepika, hello Kalpana, hello Sneha, hello Shrija, hello MD Safin, hello Siva, welcome aboard, hello Black Ops, Giant, thank you so much, hello Bhavi. Nice to see all of you. Good evening, good evening. You are present in large numbers, shows the Josh, shows your enthu, shows your commitment towards 99 percentile. And in today's lecture of Flash, we are going to start with photons, then we are going to go to dual nature, those things will go hand in hand, then we'll go to photoelectric effect, then we will go to your atoms and atomic structure, and then we will go to nucleus. So this is the order or the flow of topics. You know, certain things are deleted, certain things are not there. So obviously we'll be skipping that, and priority is given to the highest weightage topics, highest important concepts which are going to be asked from modern physics. Expect anywhere between 20 to 36 marks. 20 to 36 marks just from this lecture alone. Right? Okay, so get ready for it. And those of you who do not know me, this is Captain Shreyas, your physics master teacher. Alright, I have been teaching for a very long time and produced amazing results. And this year too, I am going to produce amazing results thanks to your love, support and dedication. Alright, so let's begin the class by smashing the like button if you have not done that yet. Support the channel, support me, support the entire JEE Warriors team by showing your love, and do not forget to subscribe. Do not forget, or else you will miss the lectures, you will miss the notifications, you will be like, oops, I forgot. And remember the PDF, yes, many people are asking about the PDF. Yes, it will be shared on the Telegram. So make sure you join the Telegram, not just for the PDF, but also for the link of the mock test, which will be shared with all of you. Yes, let's begin. And the Pandus have assembled. Thank you, Anuga. Yes, it's your capto. Yeah, and this will help for JEE Advanced 2 later on, definitely. The duration of the class, not more than 2 hours 45 minutes, okay? So let's begin. Let's begin with photons and duality. I'll start writing all the important properties. I'll explain you also very briefly. Don't worry about it. And we'll go from the scratch and scale up. And then I have some amazing questions, like you can see on the screen over here. I have put up some amazing questions which are going to come up, you know, later on. So pay attention. Let's start. First of all, remember when we talk about light or any electromagnetic radiation, electromagnetic radiation could be of many types, like your mobile radiation, or let's say your microwave, or let's say just the light which you see around you, right? Or so many other examples are there, Bluetooth, Wi-Fi, right? Long radio waves. All these are electromagnetic radiations, or basically light. This has dual personality disorder. Light has dual personality disorder. Like you might have seen some movies where, you know, somebody behaves very differently in front of someone, and in front of somebody else behaves completely differently. So light also behaves differently in different setups or different experiments. So one is your wave behavior and the other one is the particle behavior. This wave behavior was explained by Maxwell. This was explained by Maxwell and many more people. This particle behavior was explained by Planck, Einstein, and so many others. Maxwell was there, Young was there, right? So many people have explained wave behavior, so many other people have contributed in the particle behavior. And when I say light is a wave, it is an electromagnetic field wave. Electromagnetic field wave. You can use this formula. Speed of light is frequency into wavelength. How many of you remember this formula? Even from chemistry or maybe some other chapter. And even if you don't remember, it's very simple. Speed is frequency into wavelength. Frequency is measured in hertz, wavelength in meters. How long one wave is. This is the speed of light. How much is roughly the speed of light? It is 3 lakh kilometers per second or 3 into 10 to the power 8 meters per second. That's the speed of light. Remember? Very good. The particle nature of light is called as photons. The particle nature of light is basically called as photons. Like you will call one person behaving very nicely in front of the teacher, very sincere student. You will call him, some nice name, Laddu, or maybe one Chamcha, or so many other names you can call. And when he is outside, he is behaving like a rowdy. So in front of the teacher, you will call that as electromagnetic wave, and maybe outside it is rowdy. So this is that other kind of behavior. So that is photons. That's the name given to it. So photons, they have all the properties which a particle possesses. What does a particle have? A particle, has, momentum. It has momentum. It can collide. Right? And it has, you can say it has some space which it occupies. It occupies some space. Then you can also say that it can apply force when it collides. All those things, like it can apply impulse, right? It occupies space. All these things are the characteristics of the particle nature. And photons is that particle behavior. Everybody understood till this point? What is the meaning of frequency? Frequency is how fast things are happening, how many times it goes up and down. So frequency of a wave is going up and down, tuck, 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 tuck. So if I say the frequency is 10 hertz, means 10 times it has gone up and down. 10 waves have passed in 1 second. That's the meaning of frequency, right? Okay, very good. Shinan, you can also watch this for 2025. Now, what are the different properties of a photon? Photon properties. First thing, photon is nothing but a packet of energy of light. Packet of energy of light. The energy of the light does not go continuously, it goes in packets. Tuck, 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 tuck. It goes in packets. It is not continuous. It's like, during Holi, you take a water, you want to spray water on people. So you take a pipe and spray water on people. Have you done that? You take a pipe and spray water on different people. So it is continuous. Other option is you fill the water in a balloon and then throw it on Pandu, Champa, Laddu, all the friends and enemies that you have. So that is how photons go, in packets, not continuous. Is that clear? This packet of energy that is there of photon, that energy of that photon packet is nothing but hf. F stands for frequency. H is Planck constant. H stands for Planck's constant. F stands for frequency. The value of H is 6.6 into 10 to the power minus 34. Okay, it's in SI units, so it is joules second. Frequency is per second, so if you take seconds on the top, joules into second will be the unit. You also have seen that C is F lambda, so F will be lambda by C. F will be lambda by C. F will be C by lambda, my bad. F will be C by lambda. So you can also write it down as HC by lambda. That is also okay. That is also okay. Now, the value of H is complicated. The value of C also in powers of 10, 3 into something. Lambda can be in some nanometers or Armstrong. Usually, you do not substitute H and C values. usually you use a shortcut way to find it out. And the shortcut way to find it out is this formula. Energy of a photon is given by 1240 divided by lambda, provided this lambda is expressed in nanometers. If it is expressed in Armstrong, then you increase 1 0 over here, 12400. But remember, this is in electron volt. Electron volt is a very small unit of energy, because these energies are not big in joules, kilojoules. No. Very, very small. That's why electron volt. So remember this value, 1240 for nano. Armstrong is even smaller. So you add 1 0 on the top to nullify the effect, and that's when you get 12400. Use this formula because this will save you the trouble of substituting H and C values. I hope this is clear till this point. So this is the energy of the photon expressed in electron volt. Not just that, the mass of the photon is not defined, and the rest mass is assumed to be 0. This is due to relativity effects. Just remember it as a theory pointer. This is all due to relativity, Einstein's theory of relativity. So that relativity effects, that's why we assume rest mass is 0. Otherwise, the mass is not defined. We do not worry about it so much. Next important thing is all photons travel at the same speed. When you come out of the school, one Pandu goes really fast, very excited to go home and watch the TV. One Pandu not even excited because he knows after going home he is going to get scolding. One Pandu went somewhere else slowly, then maybe fast. So each Pandu might go with different speeds, but photons, they all go with the same speeds no matter where you are. All the photons go with the same speed. Is that clear? So all photons travel with same speed. That is nothing but speed of light, which is 3 lakh kilometers per second. That is another important point which you must note. Next important thing which you should know is the momentum of a photon. The momentum of a photon P is given by Planck's constant divided by lambda. Planck's constant divided by lambda. Lambda is the wavelength of the light. So light is falling. Right now light is falling on me. I know the wavelength of the light. So the photons which are coming and hitting me, they have some momentum. So the momentum is given by h by lambda of each photon. I hope this is clear. Yes. If you want, you can rewrite this like this. Multiply by C and divide by C. Multiply by C, divide by C. Why did I do that? hc by lambda. hc by lambda. It is very familiar. hc by lambda is the energy of the photon. So why not write this also as energy of the photon divided by C? That is also okay. Both formulas are fine. Good evening. Get no problem. Join in the live session. Make notes. Learn from it. Watch closely from start till the end. Modern Physics Flash Series. Next important thing about photons is that, a photon, when they arrive in bunch, in large numbers, it's like a stream of photons. That's a beam of light. So light, when you turn on the torch or when the lamp is lit, there is a nice distribution of light. Light goes in all the directions, or it might come in the form of rays, which you also call it as a beam. So beam of light will have some intensity. Intensity of light. Intensity of that light is nothing but the total energy per unit time per unit area. Total energy per unit time per unit area. So can you guess the unit of intensity? Quickly put it up in the chat box. Meanwhile, I'll rewrite or substitute few things in this expression? Guess the unit of intensity in the chat box, reading the chat box right now. Good to see you to MMS. Yep. Energy, total energy will be the total number of photons, let's say it is n, into energy of each photon, that will give me the total energy. The whole thing divided by time divided by area. So that is this. So number of photons into energy of photon by time into area. That's the formula. Energy of the photon we already know, hc by lambda. Yep, it is watts per meter square. Very good. Or so you can write it as watts per meter square, or you can also write it as joules per second per meter square. Joules per second per meter square, both are the same thing. So this is the intensity of light formula in terms of energy of photon. Keep this in mind. Next important thing, the energy of a photon, is it kinetic or potential? This question, if asked or when asked, many students make a mistake. Even dropper students make a mistake. Let's see how many of you can tell me this. Is it kinetic energy, or is it potential energy, or is it mechanical energy? What do you think it is? When I say energy of the photon, right, it's HF. Is that kinetic energy or potential energy? Oh, Krishna saying kinetic energy. Pandu, Shreyas Sir fan. Oh my God, thank you so much. Both. Yes, Ramesh, I'm back. Kinetic energy, sure. No, that is not kinetic. It is just the energy of the photon. That's it. It's just the internal energy. That's it. It's just the energy of the photon. It's not potential because it has no charge. Remember, a photon is basically chargeless, right? It does not have no magnetic properties, right? It does not even have mass, even no gravitational properties, nothing, no magnetic properties, nothing. So remember, it does not have potential energy. It also does not have, kinetic energy, because it is wrong. Many people forget this. Energy of the photon, you cannot write it as half mv square. It is invalid. It is not equal to. What is the mass? Mass is not known. Mass is not defined only. So how can you write kinetic energy as half mv square? So keep that in mind. So it's wrong to say kinetic energy of a photon is half mv square, because mass is only not known. It's not defined only. So don't worry about it. Okay. Next important thing which you should know about photons is that a photon, all right, is not going to be conserved. Very important. When something happens, let's say it collides. So the number of photons may not be conserved. That also means it can be created. It can be created or even destroyed. It can be even created or even destroyed. So a photon, let's say it collides with an atom, it might be absorbed, it is destroyed, and the electron might get excited to higher energy. An electron is very excited. It gets bored, it gets de-excited. It will emit a photon. A new photon is created magically. So photons can be absorbed, destroyed, or it can be emitted. That means created. So it is not necessary if 100 photons came in, 100 photons must go out. Some photons might just be newly created or destroyed. But, what is that but? Energy and the momentum of the system is always conserved. That's why they are universal laws, are always basically conserved. Is this part very, very clear? So photon collides with atom. It's not like the atom will not move. The atom will move. The momentum will be conserved. The energy will be transferred from the photon to the atom. That energy is conserved during collisions. momentum is conserved during collisions, but photons can get absorbed or released. I hope all these properties are clear. Yes. So, Bragdeshwar, many students even have this, same doubt, how the photon has momentum but it does not have mass. So, I don't want to go too much into detail over there, but remember, what you learned in school is wrong. Momentum is m into v only for matter. Only for matter. Matter means something which has mass. Something which has mass. This is only for matter, like you, me, bullet, gun, cannon, ball, stone, mud, rock, chair, table. They are having matter. Photon does not have matter. It is not made of protons, electrons, neutrons. It is not matter. So it is wrong to say P is equal to mv for photons. Photons are not having mass, they do not have charge, they do not have magnetic properties. So that's why the momentum of the photon has a completely different formula. Okay, so the formula that you have seen in school level is only for matter. For photons you use this. I hope that doubt is answered. It's clear. True vision, no problem, bacha. You can go back even in the live session, catch up to this current topic at 2x speed, or continue watching live. Can you see photons? Yes. That's the only way you see things around you. You don't see the photon, but when the photon enters the eye and retina detects it, the retina is capable to understand that, oh, it is this color, oh, it is that color. So our brain, our biological systems are adapted to detect which kind of photon is entering our eye, and that's how we see the different colors around you. Remember that. Okay. Now, that was all about photons. Let's talk about duality. Let's talk about duality now. What is this duality or wave particle dual nature? Okay, I will explain this to you in a manner which no other teacher would have explained this to you. Are you ready for it? And if you are ready for it, put the hashtag WPWP. Good evening, Tarak. Join in, my dear warriors. Quickly, this is the best, amazing session for modern physics for all the JEE students. Keep it up. Quanta is basically a small number, or just a number in which you can express any other thing. Like, for example, I have 10 rupee notes. So if I have lot of wealth, I will stack up these 10 rupee notes and make up my wealth. So 10 rupees becomes the quanta, is the smallest denomination, right? And everything is in terms of that number. Okay, great. Awesome. I hope that meaning is clear. Very good, very good, very good. So, my dear students, let's talk about wave particle duality like never before. Light said, I can be a electromagnetic wave, and also I can show the behavior of particles. So photons, which are like particles, photon particles like behavior. So if you see the equation lambda and h, momentum is equal to h by lambda, this particular equation. Momentum is a term which is associated with particle nature. Momentum is a term which is associated with particle nature. Lambda is a term which is associated with wave nature. Agree? Wavelength, wave. Momentum of a particle behavior, impact. Correct. So then one scientist thought, wait a minute, what about matter? What is matter? I just explained to you. Table, chair, you, books, stone, rocks, sun, earth, everything matter, made of protons, electrons, neutrons. They have some property called mass. Even he thought, maybe till now we were wrong. Maybe till now we were wrong. We only saw the particle nature of light. Maybe the matter around us also has wave nature. And then scientists began to search for the wave nature of the particles. And they experimentally were able to prove the wave nature of particles, wave nature of matter around you. The matter, mass, also has wave. Those waves are not electromagnetic. They are just called matter waves. Matter waves. So the particles, they possess mass. The particles possess mass like electron, protons, neutrons. The wave nature is called matter waves. Yes. Then that scientist which I was talking about, such a very nice, cunning fellow he is. What he did, he put in lot of effort in making that formula. That lot of effort was, take this equation, put this guy down, put this guy up. Meaning, look at what he did. Such a big effort he put in. He had to shift this lambda on the top, and he brought that momentum below. So much effort, no? You have to lift this guy on the top. You have to ask that request, please come down. So, lot of effort he took. And then he said, hey, listen, your particles which have mass, they have momentum, right? The particles which have mass, they have momentum, right? And the momentum we know is mass into velocity. Momentum. Here we can write mass into velocity. So then the wavelength will be h by p. He just interchanged, and guess what? It came out to be true. Experimentally also it was proven. So this wavelength is associated with that matter wave. This was discovered, or this was hypothesized by the scientist called as de Broglie. That's why it is sometimes also called as the de Broglie's wavelength of a particle of having certain mass. Understood? Yes, this is called as de Broglie's wavelength. Very interesting phenomena, very interesting discovery, and it was proven to be right. Okay, so de Broglie's wavelength is there for everyone. Even I have a wavelength. Even if you take a cricket ball and throw it, right? If you take a cricket ball, if I take this pen, I'm angry at a student, I throw this pen at the student. That pen also has a matter wave. Like, sir, does that mean the pen goes like this? Like this? So does that pen go like this? No! One tight slap I will give you. No, the pen does not go like that. That's something which you cannot see. That's something which you will not feel. You have to conduct complex experiments, which we will discuss some other day, but not today. But just remember, it is there. You cannot see it, you cannot feel it, you cannot, probably touch it and say that, oh, it is going like a wave. No, it's a matter wave, something very different. It's not electrical, it's not magnetic, it's not gravitational, it's something else. Just keep that in mind. Yes. Cool. Understood? So that's de Broglie. Now, remember one thing over here. Momentum for a particle is mass into velocity, correct? Can you also write this as root of 2 times m times kinetic energy? Just check this out. Can you also write momentum as 2 times m times kinetic energy? Just check this out. Kinetic energy is half mv square. Half and 2 cancel. M and m square. V and v square. So v square and m square under the root. It will just become mv. So it is correct. Just mentally you can do it, or in the rough work you can just substitute kinetic energy as half mv square, half cancels. M square v square's root is mv. That's what you can see. And you can substitute that over here. But here, remember one thing. You cannot substitute p is root 2 mk. That will be invalid. It will be invalid. That is not right for you to do that. Please remember, over here we have done this. Where is it? Slide. Yeah, over here. Momentum is energy by C. E by C. So you can, if you want, you can put this as E by C. Is this kinetic? No. Is this potential? No. It's just the energy of the photon. So you can use this formula as well. Momentum is E by C for solving problems. So understand the difference. Here I am using kinetic energy formula. Here I can't. I am compelled to use the Planck's equation for the energy. Till now, if everything is clear, shall we start with the problems? And if you are ready for the problem, smash the like button and put up a thumbs up in the chat box quickly. If you have already done that, don't smash it again. Okay, if you have done that, very good. Just put the thumbs up button in the chat box. We will begin with the problem solving. Ready, my dear warriors? Ready, my dear warriors? Very good. Chalo. Here comes the first question on your screen. Now, photon of frequency nu. Now, you know, there is always this debate whether frequency, should I use the symbol F or this nu? In physics, I will generally avoid this. I will generally use this because this symbol might confuse you with either is it velocity or is it frequency. That's the reason why we generally avoid. But in the exam, if you get this, don't say, no, this is physics paper, I want F only, what is this? I don't want nu. Don't say all that things. Okay, so that is nu, which is frequency, right? Like momentum associated with it. If c is the velocity of light, the momentum is, come on, my dear students. Henry, I don't know how long, but 100%, it will be more than 2 hours. Okay, thank you so much. Thank you so much, True Vision Media. I remember all your nice gestures that you have showered, not just today, but also yesterday. Option D says Sanjana and even Tamil Rasi and even Gayatri. Okay, thank you so much, Avteri. And the correct answer for this question, let's have a look. Yes, it is option D, frequency, momentum associated is. Okay, so momentum is nothing but h by lambda. We also know that speed of light is nothing but frequency, which is nu, into the wavelength. Okay, so therefore wavelength will be c by nu. Substitute that over here. Substitute this over here. So this will become c by nothing but nu. So if I take nu on the upstairs, so it will be h nu by c. H nu by c is option D. Very good. Awesome. Yep, very good. Let's go to the next question coming up on your screen, my dear warriors. And I'm going to teach you a very interesting thing in this problem. Let's see if you can solve this within a minute, because that's the approx time you should take in the actual exam. Okay, you take 1.5 minutes, no issues. This lamp emits light 0.6 micrometers, assuming it to be 25% efficient. To convert that energy into light, how many photons do you think will come out? I'll give you a hint. Just some time back, I gave you the formula of intensity. Number of photons into energy of photon per unit time by area. That was intensity. Think this is power. So power will not have area in the formula. Power is energy per unit time. Power is energy per unit time. Just go with the flow. You will get the answer. Trust me. Just start going with the flow. Power is energy per unit time. Energy will be photons into number of photons. Sorry, photons energy into number of photons. Just try substituting the values. I think you will get the answer. Come on, try this out. So power is nothing but the total energy per unit time. The total energy will be the number of photons into energy of each photon, this thing by unit time. Question is the number of photons of that light per unit time is asked. Therefore, n by t will be nothing but the power, this is not momentum, divided by energy of the photon. Okay, now that power is given to me. What is the energy of the photon? What is the energy of the photon? Come on, think about it. It is nothing but h into c by lambda. So lambda will go on the top. Is that okay? H c by lambda. So I've shifted the lambda on the top. That's it. I've substituted the Planck's energy formula. Nothing else. Okay. Now listen to this statement carefully. 25% efficient means if you give Pandu 100 laddus, he eats 75 laddus. And only 25 laddus he will give to Champa. That is the meaning of 25% efficient. You give Pandu 100 laddus, 75 laddus, Pandu ate off. Only 25 laddus. See Champa, I got you 25 laddus. So, if Pandu is given 200 laddus and Pandu is 25% efficient, how many laddus will he eat? 150 laddus, yes or no? How many laddus will he give to Champa? 50 laddus. So how much energy will be actually utilized in light? How much energy will be actually utilized in light? 25% of 200, which is 50 watts. 50 watts. Agree or disagree? Everybody with me? Yep. Awesome. So substitute the value of P not as 200 but as 50. Not as 200 because 200 was the electrical energy given. In that electrical energy, some 75% was lost. Only 25% went into light, which is photons. So that's why we will substitute 50, not 200. Is that problem? Is this part clear? Yep. Pandu and Champa are very, very happy. I'm pretty sure. So I will put 50 here. Then who is there? Who is there? 0.6 micrometer is there. 0.6 into 10 to the power minus 6. Whole thing divided by Hc. So that's 6.6 into 10 to the power minus 34 into C. C is nothing but speed of light, 3 into 10 to the power 8. Complicated calculation, no. But why fear when your 𝐸𝐴𝐵 sir is here? Why fear when your 𝐸𝐴𝐵 sir is here? We will do some nice magical trick. And some of you have been attending my classes from before or maybe 1-2 years, you know this trick. That is, ignore the powers of 10. Forget the decimal places, forget the zeros, forget the powers of 10. Just write down pure non-zero numbers. Just write down pure non-zero numbers. So, what are the non-zero numbers? 5 is there, then into 6 is there, then 66 is there. Forget the decimal, I know, don't worry about it. And 3 is there. Correct? So, 3 goes with 6 2 times. 5 2s are 10. 5 2s are 10. 66. 66 is very close to 2/3 of 100. 2/3 of 100, correct? So 2 by 3 of 100. Now forget those zeros. Forget those tens. Don't worry about it. Forget those zeros. Forget those zeros. Just don't worry about it. So it will become 1 by 2 by 3, which is 3 by 2. 3 by 2 is 1.5. So the answer will have either 15 or 1.5 or 0.15, and there is only one such option like that, which is B. Hence that is correct. So don't worry about powers of 10. That will automatically come out to be 10 to the power 20. That is not your headache. That is the examiner's headache to calculate that. You just find out the pure numbers. How many of you loved this method? How many of you understood this method? How many of you saw the trick? See, that's the reason why you should attend my classes. That's the reason why you should see me doing problems. That's the reason why you should subscribe the channel. And that's the reason why you should also smash the like button right now. Got it? Easy trick. How much time you would have saved? 100% you have saved at least half a minute to 1 minute. And so many chances of silly mistake in the powers of 10 and so many things. So we avoided all that. Let's move on. What will be the relation between wavelength of a photon and electron of the same energy? What will be the relation? I know there is no option. Don't get scared. Find it out. I can give you options, but there is no point. You cannot look at the options and do anything. Just you have to get the answer and you will see which option is matching. So that's the deliberate reason why I have not put any option over here. What will be the relation between wavelength of a photon and electron of the same energy? Let's try to solve this question, my dear warriors. First, let's talk about photon. So energy of a photon is hc by lambda. Let's keep it on the sidelines. Let's go now to electron. So for electron, okay, lambda de Broglie wavelength is h by p, Planck's constant by momentum. And what did I tell you some time back? Momentum is nothing but root 2 mk. Root 2 mk. But clearly given same energy. Same energy means what? Same energy means what? The kinetic energy of the electron is the total energy of the photon. Is the total energy of the photon. Okay. So why not write this as root 2 m and E over here? That is your lambda. Okay. But this is the wavelength of the electron. Wavelength of the electron. And here this is the wavelength of the photon. Wavelength of the photon. So lambda p. So if I rearrange it, I will get lambda p is equal to hc by E. What will I do next? Think about it. I feel I should divide these two. So dividing both of them. So lambda P divided by lambda E. Observe carefully. hc by E, and over here h is below and root 2 me is on the top. Root 2 me is on the top, correct? That's what it is for the electron. H cancels. You have C over here. And you will have root 2m. Root E cancels. Root E cancels. Who remains? Root E remains. So that is lambda P by lambda E. That is the final relationship between the wavelengths, between the wavelength of the photon and the electron. That is the relationship. How many of you loved this? Yep. Very good. Ready, Pali? Even if you are late, don't worry. You are not going to miss much because there are many concepts which I am going to cover throughout this series. Don't give up. You can watch the missed part later on also. But this time will not come back. You cannot say, I will replay this time and I'll get back this time. Once a time is lost, it's lost. But the lecture is not lost. It's recorded after the session is over also. So continue watching this class even if you are watching it just few minutes back. Awesome. Great. Let's move on. Let's see if you can get this. The relationship between energy of the photon and its wavelength is... Come on, I want the answer to be spammed. Yes, if you have zero knowledge about this chapter also, Teja, you can listen to this because I have started right from the basics and I am solving each and every question for all of you. Remember that. So you will have to, watch it properly, and if you want, you can also pause the video, go back and again listen to me. Yes. So what is the answer? Come on, think about it. B, Pakka, 100%. Very good. Energy is inversely proportional to the wavelength. So energy is hef, which is also hc by lambda. So you can see energy is inversely proportional to the wavelength. In fact, there was a question asked also previously. Energy graph is given, wavelength graph is given. How will it look like? It will look like this. Very good. Everybody has answered B. Congratulations, right from Hansi to Beluga, Nihal, Prasant, Shaya, Naga, Prasant, Siva, True Vision, Kaushik. Very good. Congratulations. And here comes the next question. This is very interesting. You can give the numbers in the chat box. Deliberately, I did not put options because there is no use. If an alpha particle and proton both are accelerated by the same voltage difference. So imagine there is some voltage difference, you accelerate it because of the voltage, it accelerates, it gets some speed. And once it gets speed, it has momentum. And once it has momentum, it has the de Broglie wavelength. Keep that in mind. Okay. So question is, what is the ratio of the de Broglie wavelength? Okay. Before finding the ratio, let's derive the formula step by step and then we'll take the ratio. Usually for ratio problems, that's Capto Shreyas Sir's trick. Usually I don't take the first step as the ratio problem. I just try to see what is the relationship and then I divide it in the end, not at the beginning. That is usually easier and less time consuming. So if I take a particle of mass m, charge q, and I accelerate it by potential difference delta v, by the time it reaches here, it will have some speed and therefore it has some de Broglie wavelength. Cool. So here is what my logic says. Lambda is nothing but h by p, which can be also written down as h by root of 2 times mass times kinetic energy. Now, when we talk about that kinetic energy, where did that kinetic energy come from? Potential difference. That means potential energy. So can I write it as U? Can I write it as the potential energy which it has gained because of the acceleration? Right. Now what is potential energy? When you accelerate it, the charge is Q, potential difference is delta V. So the potential energy that we are talking about is charge into voltage difference. Charge into voltage difference gives you the energy which was there, which went into kinetic energy, correct? So hence, I'll just put it as Q delta V. Q delta V. I think I have got my relationship. de Broglie wavelength right over here. Then same potential difference, find the ratio of it. Okay, so many terms are same, like H is a constant, 2 is a constant, delta V is clearly given to be same, are accelerated by the same potential difference, So therefore, I get lambda is inversely proportional to root of mass and charge. Inversely proportional to the root of mass and charge. So, my dear students, if I have to divide lambda of alpha upon lambda of proton, here you will have, okay, just one second. Here you will have first mass of alpha, and here you will have mass of proton, and here you will have charge of alpha and charge of proton. What is the mass of proton and mass of alpha's ratio? That ratio is 1:4. Proton, if I take it as M, there are 2 protons and 2 neutrons in an alpha particle. Alpha particle means whom? Helium, but without the electron. Without the electrons, right? So 2 protons are there in the nucleus, 2 neutrons are there in the nucleus, 2 and 2, 4. Proton and neutron roughly same mass, right? Proton and neutron roughly same mass. So 4 times the mass of a single proton. If you talk about the charge, proton has +1 charge, imagine, or plus E charge. A helium ionized nucleus or alpha particle has 2 protons, 2 neutrons. Neutrons don't have any charge. Take it out. Who are remaining? 2 protons. So that's why 2 charge is there. So it is just the ratio that I'm bothered about. √4:2. So 1/2 √2 is lambda alpha by lambda p. That is the answer. How many of you got this now? Everyone? Everybody understood how to solve this question? Very good, very good, very good. Keep it up, my dear warriors. Brilliant question, because it involves little bit of electrostatics here. It also involves de Broglie wavelength here. And it also involves your basic knowledge about atoms or nucleus, that how many protons, neutrons, etc. are there, and their charges and all those things. Very nice. Yep. What is the weightage of modern physics, Bungula? At the start only I mentioned this, 20 marks to 36 marks. That's the range that you can expect. Let's begin with photoelectric effect. All right, ready? Let's begin with photoelectric effect. Let's start with this. Now, there are multiple ways by which electrons can be ejected out. Multiple ways by which electrons can be ejected out, or can be emitted, or can be given as a beam or rays, by different processes. One of the way for emission of electrons, is by heating an object. You heat an object, what will happen? The molecules begin to vibrate. They will start, rubbing against each other. They will collide with each other because they have a lot of kinetic energy. And in that process, these electrons, Pavum electrons, they are the most vulnerable, and these electrons get ejected out, thrown out. That kind of electron emission is called as thermionic emission. Thermionic emission because of temperature. So, because of whom? Temperature. You heat a body, electrons are ejected because of collisions and all of that. Everybody? Very good. There is no charge on the photon account. Charge on the photon is 0. No charge, neither positive nor negative. The second type of way in which you can emit an electron is via field emission. And the best example for that is lightning. When clouds rub against each other, what happens? There is lot of static charges which are stored. There is a very strong field which is created from the cloud to the earth. And when the field becomes very strong because of too much rubbing, then it will propel, it will push those electrons right from, the earth to the cloud, or from the cloud to the earth, depending on the charges or the direction of the field. And that's when and that's when lightning occurs. So when you, or even sparks, if you take two wires very close, sometimes you see the sparks because the field has become very strong over there, and when the field becomes very strong, the electrons from that conducting element, they jump to the other conductor, even when there is vacuum or even when there is air which is not conducting, So that is field emission. And the last one is photoelectric emission. Photoelectric emission. Photo means what? Light. Photo means what? Light. So when light falls on a surface, that light energy is used to chuck out an electron, just like how your teacher says, go out, get out of the class. Same way, light will say, get out of the body. That is called as photoelectric emission. Is that clear? These are the three ways. By which by which electron emission occurs. This is there also in your NCERT. Now let's talk in detail about photoelectric effect. So photoelectric effect. The word photo means light. Light is incident. So let's say this is your light. Which falls, and it falls, let's say, on a body over here. It falls on a surface. And this next part, electric, that means electrons. Those electrons which are ejected out, they are sometimes also called as photoelectrons because of light they are coming out. That is why they are called as photoelectrons. So you might see electrons coming out in different directions with different speeds. This is nothing but your electrons which are being ejected out. So photoelectrons are going to be ejected out. Now it is found that this photoelectric effect only occurs under certain circumstances, and that circumstance is this: only when the frequency of the light is more than or equal to something called as the threshold frequency, you will see the photoelectric effect will occur. Vice versa, wavelength wise, it should be less than or equal to the critical or the threshold wavelength. Understand that? So if it is less than that wavelength, only then the photoelectric effect occurs. When I say the frequency of the light should be more than certain frequency, which I am calling it as the threshold frequency, it also gives you an idea that the energy of the photon must be more than or equal to a certain amount of energy. Only then the photoelectric effect occurs. For example, has it ever happened that you want to go to a party, or you want to go to an event, or you want to go to a function? Maybe there is some cultural event in the school and you want your friend also, but you know that friend is not going to come. So what do? You will go to his house. You will tell his parents, no, auntie, uncle, please let him go. I will make sure that he does not do anything. He will be safe or she will be safe. Don't worry. We'll come back before 7 o'clock. Don't worry. We'll not eat outside. Have you done this? Yes or no? Just tell me. So you pursue it, right? Same way, light will ask the surface, listen, don't worry, nothing will happen. Please let that electron go, etc. So that convincing power, that persuasion power, if it is higher, only then that electron will come out. The atom won't let go of that electron so easily. You need to put in some effort, minimum effort. So that minimum energy, which is phi, is also called as the work function. That's the minimum energy required. Without that, you will not see that photoelectric effect happening, or the frequency should be more than the threshold frequency. And because energy is inversely proportional to the wavelength, so wavelength should be small so that the frequency is high, so that the energy is high. That's the criteria for the photoelectric effect to occur. Keep this in mind. I hope till this point everything is clear. Now, Einstein gave the photoelectric equation, and it happens to be something like this. See, if this is the light which is falling, and the light which is falling, each photon has the energy hf, and so on and so forth. So this is the light which is falling. This surface has its work function given by phi. Oh, you should know this work function, right? This work function completely depends on the surface only, not depends on anything else. Some kids are very easy to convince their parents. You just have to go, auntie, can I go out with your friend? Okay, yeah, take him and go. He's anyways causing a lot of mischief. Some parents, you have to like convince them, listen, please let me go, auntie, please, auntie, please, auntie. So there you will have to put in a lot of effort. Okay, so the effort will be different at different places. So same way, different surfaces have different work function. Understood, my dear students? Different work function. So the metallic surfaces, nature decides that work function. So what you get outside is the electrons, okay, electrons with different speeds, different directions. So if you write down the equation, energy of the photon is equal to the work function. Some energy went in pulling that electron out, or throwing or getting that electron out, right? If you had 100 joules of energy, maybe 20 joules was just used to take it outside, and the remaining will go in what? Kinetic energy. But that's not all. Even when it comes out, there might be some loss, because these electrons might collide with each other. These electrons might hit the atom. Maybe it emits some radiation during the acceleration. So many things can happen. So many losses can happen. Plus losses. This is nothing but an energy equation. 100 joules of energy was incident. Example, 20 joules went in taking it out. Maybe 10 more joules was lost. So 20 was taken. 10 is also taken. So remaining 70 is the kinetic energy. Sometimes the loss is more, sometimes the loss is less. The luckiest electron will have more loss or less loss. Luckiest, that electron which did not meet anyone, did not collide with anyone, that will be the luckiest electron. The loss for such an electron will be more, or will it be less? Put it up in the chat box. Put it up in the chat box, my dear warriors. Obviously, it will be least. So, for the luckiest electron, this is the equation that will be valid. Energy of the photon will be nothing but the work function plus the maximum kinetic energy. This is for that lucky electron. I hope this is very, very clear. Exactly. It will be in fact 0. The least possible loss is 0. It did not meet only anyone. Furthermore, we can also, substitute the value, like energy of the photon is hc by lambda. If you talk about the work function, how much will it be? How much will it be in terms of f naught or lambda naught? It will be h f naught. That's the minimum energy required to pluck it out. You can also write it as hc by lambda naught. That is the minimum energy needed to pluck out, right? hf is the energy of the photon. If that energy falls on the surface, then it will just come out. So the energy of the photon usually is higher for the effect to occur. So that minimum energy will be hf naught. F naught is the threshold. Correct? Keep this in mind. So why not substitute this over here as hc by lambda naught also. Now the last thing, how do I know how much is the kinetic energy? How do I know how much is the kinetic energy of that luckiest electron? So account will be solving a problem like that. You will see that frequency and kinetic energy are not directly proportional because there is a constant in between. So you will be seeing a problem very soon like that. Yes. I'm so happy to see you too, Rishi. Thank you so much. So my dear warriors, how do I measure the kinetic energy? So for measuring the kinetic energy, what you do is, if the electrons are ejected out like this, right, from a metallic surface over here, you connect or you have another metallic surface and ensure that there is a battery or potential difference created across that metallic surface, so that these electrons decelerate, they slow down, eventually just before reaching this point they take a U-turn. Basically they are not able to reach on the other side. They make a U-turn. That means the voltage difference that you have applied is enough to stop the electrons, just stop the electrons from reaching the other side. So the voltage that you apply over here is also called as the stopping voltage. This is also called as the stopping voltage or stopping potential. So that stopping potential ensures that the electrons don't reach the other side. And the formula for that is the charge into the stopping potential. The charge into the stopping potential is the kinetic energy. It is very simple to visualize this, because whatever potential drop will be there will be converted into kinetic energy, or whatever kinetic energy will be there will be converted into potential energy. So all I am doing is the electrical potential energy just got converted into kinetic energy, or I can say the kinetic energy just got converted into the electrical potential energy. So electrical potential energy is charge into voltage difference. Standard formula from electrostatics. We are using this for the second time in the class. Charge into voltage difference is the electrical potential energy which was there because of this potential difference, and that came from the kinetic energy. That kinetic energy got converted into potential energy. So you can use this. So what is the charge? What is the charge of the electron? The charge of the electron is E. So E into Vs is the kinetic energy. So I can just write it as EVS. This is basically your photoelectric equation, either this or this, whichever you want, and this is your Einstein's photoelectric equation. Einstein's photoelectric equation. For this he won Nobel Prize. Simple energy equation, but it is very nice and tricky. For this equation he won Nobel Prize. Yes, correct. Very nice. I hope you all are able to revise, understand, okay, because I'm going very systematically explaining you all the terms which are needed. Okay, so that is the Einstein's photoelectric equation. Now there are certain graphs which you must know in this chapter. I will show you all the possible graphs. Okay, all the possible graphs. First graph is for current, this is current versus intensity. Current versus intensity of the light which is falling on it. Intensity of the light which is incident on it. Now what is this current? Current is basically, look at this. The electrons are coming out from the metallic surface. When the electrons come out from the metallic surface, there is a flow of charges. what is the flow of charges called? Come on, put it up in the chat box. What is the flow of charges called? What is the flow of charges called? Jasmine, we will start with the high weightage topics first. There are only 9 to 10 topics which we need to do for 99 percentile. Remember that. So we are focusing on that first. Yes, it is called current. Right, very good. So basically all I am saying is this is the current which is coming out because of the photoelectrons. There is a light which is falling on it. Think about it. If there is no light, there will be no current. No light came, no current. More light fell, more photons interacted with the atoms, more electrons will come out. It's natural. If instead of 100, 200 photons fall, more electrons, proportionately, more electrons will be ejected out. So hence the graph is a straight line. Hence the graph is a straight line. Current is directly proportional to intensity. This is one of the important graphs which you should know. One of the important graphs which you should know. Keep this in mind. Then the next graph which you must know, very important, is this one. Again, you have current. Here you have potential. Here you have potential. Here you have current, I, and you have potential. But this time I will show the graph on both positive and negative side. That's the first quadrant and the second quadrant. When I am in the first quadrant, the potential values are positive. When I am in the other quadrant, this side, potential values are negative. What do they mean? If the potential is positive, means the electrons are not decelerated, they are accelerated. So the polarities matter, meaning this is positive terminal, this is negative terminal. If positive is here, negative will repel the electrons, the positive will pull the electrons. So the electrons will move faster. Agree? Electrons will move faster, they will be accelerated. But if I make this negative and this positive, if I make this negative and this positive will pull this electron back, and this negative will repel that electron back. So it will try to stop it. So for negative voltages, it will try to stop. For positive voltages, it will try to accelerate. I hope the difference is very clear. This difference should be very clear. Correct. So the graph looks something like this. When you do not apply voltage, still there is some current. Obviously, there is no need of voltage. Even when there is no voltage, electrons are still going to come out. They are not going to be like, oh, no potential, I will not come out. Nothing like that. They will still come out. You increase the voltage, they will definitely increase slightly and it will go like this. You make the potential, oh, why is it becoming straight line? Why is it becoming straight line? You think about it. Because, why is it reaching a maximum value? Because after a point, even if you increase the voltage, even if you try to accelerate, there should be electrons, no, to accelerate. It will reach a saturation point, no. Think about it. If 100 photons fell, 100 electrons maximum can come out. You accelerated all of them. You told all the 100 electrons, come over here, go to the other side. Maximum voltage you have applied. Maximum current has flown. If you increase, nothing more will happen. No more current will flow because all the electrons are now flowing and making up that current. So that's why it reaches a maximum value, which is also called as the saturation value or the saturation current. This is also called as the saturation what? Current. Keep this in mind. Everybody with me? Very good. Then you take this behind, this graph will go and hit it over here. Do you see what is so special about this point? What is happening? At this point, the value of the current is 0. The potential has reached a negative value. So this is nothing but minus Vs. Vs is the stopping voltage. Vs is the stopping voltage. If I say it is 5 volts. So minus 5, just considering the sign. Otherwise, stopping voltage is 5 volts, reversing the direction of the motion of the charges. It is trying to stop it. If it is coming, it's trying to stop it. That's minus Vs. That's how the graph looks like. Can you guess what will happen if I increase the intensity of light? If I increase the intensity of light, what do you think might happen? The graph will go like this. The value of current will increase. We just saw current is directly proportional to the intensity. So if the light is more intense, this is more intense light, then you will see the current will be also proportionately higher. Interesting thing, the stopping potential does not change. Why won't the stopping potential change? Why won't the stopping potential change if I increase the intensity? This equation will give you the hint. This equation will give you the hint. Light is the same color I am using, only intensity I am increasing. So lambda has not changed. Metal is the same, lambda naught is the same. Will Vs change? Obviously no. This did not change. This did not change. Why should this change? Incident light is the same. Yes, light is more, but color is same. So lambda is same. Metallic surface is the same. So why should potential change? So stopping potential is not dependent on the intensity of light. This kind of question has come in JEE. This kind of question has come in JEE. Right? Jyoti Organti, stopping potential, I have explained it right over here. Just rewind the session back. Is the potential required to stop the electrons, just stop the electrons from reaching the other side, okay, of a photoelectric setup. From metallic surface it is ejected, from the other side you catch it. If you are able to catch it, then the circuit is complete, current will flow. But if you stop it from reaching here by applying reverse voltage, that's it. It makes a U-turn, there is no current which will be set up in the circuit, the current won't flow. So that's the stopping potential, right? Great. There is one more graph. There is one more graph. Yeah. Yes. What about frequency? What about frequency? If you change the frequency, then obviously stopping potential will change, like you can see in this equation. Like you can see in this equation. If you change the frequency, wavelength will change. If wavelength changes, clearly stopping potential will change. So you can see the relationship between wavelength, frequency and stopping potential. Definitely. If frequency increases, stopping potential will also increase. If frequency increases, stopping potential will also increase. Keep that in mind. Right? Okay. Now one more question, one more graph which I need to give you, and that is this one. Observe this carefully. Observe this carefully. We know that energy of the photon is the work function plus your maximum kinetic energy. Energy of the photon is hf naught. Energy of the photon is hf. Work function is hf naught. Maximum kinetic energy is EVS. Maximum kinetic energy is E times Vs. Everybody remembers this? I just told you this right over here. Yes, the maximum kinetic energy. This is not just any energy. This is your max kinetic energy. This is your max kinetic energy is E times of Vs. We just saw that over here. Kinetic energy getting converted into potential. Now let's rearrange this equation and see what happens. So what I'm going to do is shift this guy over here. So it will become hf minus hf naught is equal to EVS. Divide by E on both sides and I will flip the equation. So Vs will be h by E times of f minus h by E times of f naught. Now just compare this equation with, instead of stopping potential, you write down the variable y. Instead of frequency, you write down the variable x. Instead of h by E, you write down the variable m. Instead of hf naught by c with the minus sign, you write down the expression c. So y is mx plus c, provided you make stopping potential y-axis, frequency the x-axis. So that means if I draw a graph of stopping potential versus frequency, that graph will be a straight line, but with a positive slope because m is positive, but with a negative y-intercept. That's why negative y-intercept and positive slope. So this slope is constant for everyone. You can see it is h by E, but this y-intercept will be different for everyone because f naught will be different. So this is minus h f naught by E. Yes, that's what it is. So please remember this again. I'll repeat. This part will be different for different surfaces, but the slope, this will be constant for all, because h is a Planck's constant, universal. E is also universal constant. So remember that it will not be different, but this will be different. Great. Very good. So how many of you learned many things, revised many things? How are you finding the speed? How are you finding everything over here? Do let me know in the comment section also. And shall we start with the problems now? Perfect. All right. Here we go with the questions now. Here it is. Light of two different frequencies whose photons have energy 1 electron volt and 2.5 electron volt. They are incident on a metallic surface whose work function is 0.5. So once you take one light, second time you take another light and make it fall on a metallic surface. Obviously the electrons which will come out will be of different energy. So that's the thing. What's the ratio of the maximum speed emitted by the electrons? Yes, why slope comes constant for two different? Yes, it can come in the examination, definitely. And that was the proof, by the way. Cool. So how to solve this? We know that energy of the photon is work function plus kinetic energy, and kinetic energy is nothing but half mv square. That is what it is. So think about it. The kinetic energy, which is half mv square, won't it be energy of the photon minus the work function? Kinetic energy of the photon minus the work function. Okay, so for the very first light, which is of 1 electron volt, half m v1 square will be energy of the photon. How much it is? 1 electron volt minus work function. How much it is? 0.5 electron volt. So 1 minus 0.5 is 0.5 electron volt. This is the first equation which I wrote for the first light which is falling on the metal. Now there is another light which is of 2.5 electron volt. So for the second light, the kinetic energy will be half mv2 square. Obviously speed will be different. If light is only different, speed of the electron will also be different. Kinetic energy will be different. Okay, so my dear students, what will you write over here? This will be 2.5 minus, or electron volt minus work function 0.5 electron volt, which is 2 electron volt. Wow, what do I do next? Just divide 1 and 2. This and this, if you divide, what will you get? v1 square by v2 square, because half m cancels. Here 0.5 and 2. 0.5 divided by 2, electron volt will cancel. So this will become 1 by 4. Therefore, v1 by v2 will become 1 by 2, taking roots on both sides. This is square is 1 by 4. So the roots, when you take 1 by 2, which is C for, just don't write option C, yaar. C for Captain Shreyas. Proton did not have mass. Yes, proton definitely has mass. Yes. You found the black sheep. That's C. Very good. Proud of you guys. You have found the correct answer. Awesome. Moving on to the next one. The voltage of a photocell. That means this is one side, this is another side. You connect it via some battery, right? You have some battery over here. You change it, right? You change it, and there is light falling onto it. And the electrons are ejected out. This is nothing but your photoelectric setup. So if you change, what are you saying? The wavelength, then the current will change by which graph? I know I have not given you this graph, but you have to think logically. You cannot expect only known graphs will come in the exam. If some random thing versus a random thing comes in the exam, you should be able to think what might be the correct answer, right? And that's what JEE is all about. JEE is all about. Okay, think logically. How will the current change with respect to wavelength? I just know one thing. Photoelectric effect occurs only if wavelength is less than or equal to threshold wavelength. Photoelectric effect does not occur if the wavelength is more than the threshold wavelength. Now, if you notice over here, there must be a critical wavelength after which no photoelectric effect should occur. In fact, if you see over here, after a critical wavelength, photoelectric effect is occurring. It is not correct, guys. The photoelectric effect should occur before that wavelength, not after the wavelength. Only then current should be there. This is 100% wrong. This is 100% wrong. If you notice this, it says photoelectric effect is occurring for all the wavelengths, right from 0 to everything. So this is also wrong. What about this? What about this? You know, here photoelectric effect is not occurring after certain wavelength, but this is something problematic. Why is it becoming maximum? Why is it becoming 0? If the wavelength is very small, frequency is very large. When frequency is very large, why should the current become 0? In fact, it will have even more current, because more frequency means more energy. So why is the current becoming 0 for small wavelengths? There is no reason for that. In fact, it should be much higher. It should not be 0 current. So this point is wrong. If you see over here, it kind of makes sense that this is the dead zone when there is no photoelectric effect occurring, and this is that green zone where photoelectric effect is definitely occurring. So this is the only option which matches correctly. So it should be D option. Exactly, it should be D option. Very good, Kalpana Durgamba. Very good, Diveri. Very good, Manjula. Very good, Luxury Hitler. Yes, D for Dragon Warrior. D for Dearest Captain. Thank you, Anugma. That was a very creative comment. Thank you so much. Moving on. Next question. Work function of a metal is 4 electron volt. For photoelectrons to come out with 0 velocity. 0 velocity means just come out. 0 velocity means they should just come out. Just that minimum energy is there. How much light wavelength should be falling on that metallic surface? Just think about it. Just think about it. They should just come out. Just means, you have energy of the photon, which is equal to work function plus kinetic energy. This should just come out. That means this is 0. So the energy of the photon hc by lambda should be equal to phi. Now we know what to do next. We have to find that wavelength, and this is in electron volt. So I know when things are in electron volt, I can also use a simplification formula or simplified formula where I don't have to substitute h or c or convert lambda in some meters and then convert it in electron volts. All that nonsense can be avoided by just writing this as 12400 divided by lambda, but this will be in Armstrongs, keep that in mind, will be that work function. Work function is how much? It is 4 electron volt. So the formula that I have used is hc is nothing but 12400 provided wavelength is in Armstrong and energy will be in electron volts. So now you can see that things will get cancelled. So lambda will be 12400 divided by 4. So lambda will be how much? 3100 Armstrongs. 3100 Armstrongs. C for Captain Shreyas is the correct answer. Very good. C for Capto. Very good. Account Shaya got it correct. Very good Vaishnavi. Very good Satyagavisan. Very good Rishi. Very good Gade. Gokul, Manjula, Nishant, Nishita, Vaishnavi, Nihal. Very good, Devri. Awesome. Moving on to the next question coming up on your screen. Photons of some frequency nu fall on a metallic surface for which there is some frequency of threshold nu naught. Theoretical question. Read each option carefully. This is standard. This is obviously correct. Only one of them is correct. All the electrons have same kinetic energy. That's the first option. Second option. The electrons which are ejected have distribution from 0 to this value. The most energetic electron have kinetic energy h𝛎. The average energy of the ejected electrons is h𝛎0. If you have paid attention to the lecture carefully, 100% you will get this. Oh, Spurti. Oh, definitely get Spurti. Definitely, I'll address you as Spurti. All right, come on, my dear warriors. What will be the correct theoretical answer? This is a proper theory question. If you know the theory, you get it, else you will get stuck. Mugandan, yes, Bacha, you can call it one shot, you can call it marathon, you can call it, detailed revision, you can call it zero to hero, whatever name you want to call, you can call it. But this is what we call as the flash. It's a very good combination of all these elements in one lecture. So that's what flash stands for. It's quick, it's super fast, but at the same time, it's from zero to hero. And at the same time, they are not 45 minutes classes. They are little lengthy, but at the same time, it's not very long so that you waste your time. So that's what flash stands for. Okay, so the correct answer is option B. How many of you dream of IIT Bombay? How many of you dream of IIT Bombay? So B for IIT Bombay is the correct answer. Very good, my dear students. Because I just told you some time back, right over here, where did we go? Yeah, over here. The kinetic energy of the electron will depend on the losses. Some have less, some have more. The luckiest one has the maximum kinetic energy. So imagine there will be an electron which has lost maximum. That kinetic energy will be 0. Right? So it will start from 0 to a maximum value, and that maximum value will be the difference of the energy of the photon and work function. Yes, so that is correct, definitely. So for max loss, the kinetic energy will be 0 for maximum loss, and for minimum loss, I can say the energy of the photon is equal to work function plus maximum kinetic energy. So maximum kinetic energy will be energy of the photon minus work function, which is h𝛎 minus h𝛎0, which is exactly this value. So it is correct. Yep. Yes, Nitesh. I mean, my dear warriors, I would love to know your real names, and you better put it up in the, your YouTube name. Maybe you can have your pseudonym underscore this name. Otherwise, I will keep playing match the following. True Vision is Nitesh. Okay, Gade is Spurti. So, I'll have to play match the following. I already have too many things to remember, but yes, some students are very regular. I know their names, but yeah. Anyway, sodium and copper have work functions of this and this. Ratio of the, I think one word is missing over there. Ratio of the threshold wavelength. Ratio of the threshold wavelength is close to what? Sharin, even if you start preparing today, I guarantee you more than 90 percentile. In fact, I can tell you, even from today, you can get 99 percentile just by following certain topics. I'll be making a small video of, the few topics which you should study for getting 99 percentile. And those topics, I'll tell you the order in which you should study and which topics you can leave completely and how you can make the timetable. So short video is coming very soon within the next 1-2 days. Don't worry. Okay. Why not A for the previous one? All ejected electrons have the same kinetic energy. That is wrong. Same. This word is only wrong. This word is wrong. How can it be same? It has to be different, right? It can't be same. It will be different. It will be a range of values. That's the reason. Okay. So the correct answer for this is 2:1. And I think many of you have written 2:1. Some of you are saying option A. No, it is not option A. See, the formula that you will be using, work function and threshold. Work function is hc by lambda naught. So therefore, I can say lambda 1 by lambda 2 will be phi 2 by phi 1. It's inversely related. It's inversely related. Lambda and work function. So lambda 1 by lambda 2 will be phi 2 by phi 1. Phi 2 is 4.5. Phi 1 is 2.3. How much will it be approximately? 2, no? 23 2s are 46. So very close to 2. So hence the answer will be 2:1. 2:1 is the correct answer. I hope this is very, very clear. Yes, we'll be doing it for all the top weighted chapters, and by the second attempt, hopefully we'll do it for all the chapters. Don't worry, my dear warriors. Here comes the next question coming up on your screen. This is another question. I think somebody was asking about if, wavelength of the light doubles, then will the energy double, kinetic energy of the electrons? The answer is no. And you can see the expression is quite complex. It is not a simple linear equation. So that's the reason why this problem I told you to wait for. So two photocathodes, meaning two metallic surface. Don't get boggled by this complicated words, photocathode. So what is this photocathode? It's just a metallic surface on which the light falls. Electrons come out because electrons are ejected. That's why it is called cathode. Photo because light is falling. So don't brainstorm over that. Okay. F1 and F2 are the two lights. F1 and F2 are the two lights falling onto it. Speeds are V1 and V2. Question is, what is the correct relationship? Let's see how many of you can get this. Thank you, Karthik, so much for all the love, for showering all that love. Thank you so much. Hello, Navya. You have solved this in HCV. Very good. Thank you so much. Yes, Gokul, I'll be putting up the topics for 99 percentile very soon. So the logic is energy of the photon is work function plus standard photoelectric equation by Einstein, for which he won the Nobel Prize, plus the kinetic energy. Energy of the photon. Okay, let's write it down as HF. Work function, I think, work function, let's just put it as phi. Kinetic energy, half mv1 square, or just half mv square. Now, if I write this equation two times for two different lights, like this, HF is equal to phi plus half v square for two different lights. For F1, speed will be V1. For F2, the speed will be V2. Now this is equation 1. I will call this equation 2. 1, 1, 2, 2. Equation 1, equation 2. Phi is not even there anywhere. So the obvious choice, next step, will be just subtract these two. So equation 1 minus equation 2. Phi cancel. Tata. Bye bye. So subtract these two. What will you get? What will you get? HF1 minus HF2 will be, phi has gone, half mv1 square minus half mv2 square. Take things common. HF1 minus F2 will be half mv1 square minus v2 square. Oh my god, that simple is it? Correct answer is option A. That's it. A for apple. A for top G. Oh my god. Yeah, just had to subtract, Mohit. Very good. So, my dear students, this is one of the very easy questions. How many of you would have left the question looking at the options? Put your hand on the heart and tell me. In the exam, if you would have seen this, wouldn't you be scared looking at the options? And you would be like, something complicated is there, oh my god, leave it. But that's the thing. Often, the more complicated a question looks, actually it is very laddu. When it is very simple, one line question will be there. Options will be in like 1 or 2 words or one simple value, 2, 3, 4, 5. That will be tricky. Happens. I'm not saying always, but that can happen. So don't make your mind that, oh, complex expression means it will be very difficult problem. Some of you say that, no sir, we wouldn't have left this. Good. If you wouldn't have left this, I'm proud of you. Moving on to the next one. And that is from atoms and spectra. So reaching atomic spectra, atoms, all of this. Ready, my dear warriors? Ready? Why did I subtract Manchula? Think about it. Look at the options carefully. Do you see anywhere work function? Do you see the work function term anywhere? No. But in the photoelectric equation, we get work function. I don't want it. I want to get rid of it. So what is the best way? You subtract these two equations. So phi minus phi, 0. So that's why phi does not come. F1 is there, F2 is there. F1 is there, F2 is there. F1 is there, F2 is there. V1 is there, V2 is there. V1 is there, V2 is there. That's the reason why I subtracted. Got it? Okay, very nice. Let's begin with the next part. and that is atomic spectra. Dual nature over black ops at the beginning only. I think you might have come little bit late. We did it over here. Like, where did it go? Yeah, see? Here, dual nature. We started at the right, in the beginning, dual nature. And at the first slide only, I started with dual nature. I told you light has dual nature and all of that. Okay? So we started it at the beginning, all the explanation part. If you want to listen, please rewind back, you will definitely get it. Chalo, let's go with atoms and spectra now. Okay, ready Anubha? Very good. Awesome, clearo, fire emoji in the chat box. Let's get fired up, let's get warmed up for the next part, atoms and spectra. Now, the first part is purely theoretical part. Please read line by line from NCERT or H.C. Verma. Very, very important, but theoretical. And that's something which you also study in chemistry. What are the things that you need to study line by line from NCERT? Number one is the different atomic models. Okay, so it starts right from, you know, your Dalton's model, then your Thomson's model, and then your Rutherford's model, and then finally you come to Bohr's model of atom. For each theory, for each model, you should know what are the reasons why they chose it, and you should also know the shortcomings of each model. You can make a chart, you can make a table, and you can put it up nicely in your notes. Like for example, Thomson's model, it was able to explain the conduction of electricity. It was able to explain why electrons are easy to knock out. It also explained electrical neutrality. It said that atom is neutral. It also talked about why electrons are more mobile, all of these things. But the shortcomings was, it was not able to explain the different orbits, the different energy levels, the atomic spectra, and so many other things. Similarly, Rutherford used the gold foil experiment, and he was able to say that, you know, the electrons are not spread out evenly, and, you know, the positive charge is not spread out evenly. In fact, the positive charge is concentrated at the center. He was the one who told, you know, very accurately that atom is more empty and the electrons revolve, you know, using the electrical force of attraction as the centripetal force. But he was not able to explain why the electron is not collapsing onto the nucleus, why there is no Maxwell's radiation, why the different discrete energy levels are there, why there is atomic spectra which is different for different elements. There were shortcomings in Rutherford's model also. Bohr was able to explain the atomic spectra. He was able to calculate the radius of hydrogen, energy of hydrogen very accurately. And it had many more advantages over the previous models. But again, it also had shortcomings, like it failed for higher models like lithium, helium, or even iron. For heavy elements, it was not able to calculate the radius energy properly. It was not able to explain, you know, about the orbitals. Like actually electrons don't go in orbits like that. In reality, there is always a probability. So basically, Heisenberg's uncertainty principle, it disobeyed. Like, how can you find the momentum and the location simultaneously? So there were shortcomings in this also. Okay, will you be able to read through it? I have explained you briefly that there are certain good things and bad things about each model. So please make that chart. I will more specifically focus right now on Bohr's model because that's where the maximum questions will come from. 99% questions come from Bohr's model. Keep that in mind. 99%. Cool? Yeah. So ignore that. Right. Chalo. Let's talk about Bohr's model. So in Bohr's model of atom, according to Bohr, what and all things he told? Number one, he told that the electron revolves in orbits, or rather fixed orbits, using the electrical force for centripetal acceleration. So with this, he said electrical force is mass into centripetal acceleration. So 1 by 4 pi epsilon naught. What will be the charges between which the attraction will occur? Nucleus and the electron which is revolving. Nucleus has how many protons? Z into E. Z is the atomic number, E is the charge, so Ze into electron. Z is the charge on the nucleus into electron charge. So Q1, Q2 upon R square. R is the distance which also is the radius. R is the distance which is also the radius, because if this is the nucleus which has so many positive charges, the electron will be here and it will be going with some velocity and the distance will be R. Distance will be R, correct? That's what it is. So this is how the electron will go, correct? And this will be equal to m into v square by r. That is the first postulate. Next thing he told was, that the energies in these fixed orbits are discrete and fixed, and the electron is stable. Electron is stable and doesn't emit any kind of radiation. Electron is stable and it does not emit any kind of radiation whatsoever. That's another very, very important postulate. Or else, by theory of radiation, if a charged particle accelerates, then it should lose energy and slowly collapse into the nucleus and the atom is vanished then. Okay, so that does not happen. Keep that in mind. So this is again something which he told. Then he also told about the angular momentum. The angular momentum is integral multiple, and angular momentum of the electron is integral multiple of Planck's constant by 2 pi. So from that you get L is nothing but n times h by 2 pi, where this n is nothing but your principal quantum number. Like for K, n is equal to 1. For L, n is equal to 2. For M shell, n is equal to 3. So this is your shell, K shell, M shell, L shell. These are the principal quantum numbers. You have studied that in atomic structure as well. It is nh by 2 pi. If you want, you can write L as m times v times r is equal to nh by 2 pi. nh by 2 pi. Keep these things in mind, everyone. In fact, using this with de Broglie, very important result comes out. Using this with de Broglie, you get one very interesting thing. And that interesting thing is as follows. Observe this carefully. Here you have the nucleus. And here, let's say the electron is revolving. In the orbit. This is the orbit of the electron. You can combine this with de Broglie and you can very easily prove this important thing. And that important thing is, if you measure the de Broglie wavelength of the electron, remember electron is moving, so there is a matter wave. So the matter wave of the electron, everybody with me? Matter wave of the electron. Thomson and Rutherford only studied for other exams like BITSAT, SRM, VIT. That's the reason why I did not focus on that. 99% anyways, even if it was not reduced, questions don't come from Thomson and Rutherford. So very rarely you get questions. So anyways, it is in the reduced syllabus, so ignore. But for VIT, EEE, SRM and all that, you might need it later on. That's why I just mentioned about it. Okay. So it so happens that the de Broglie wavelength exactly fits in as many number of times as the principal quantum number. So you can see This is the de Broglie wavelength I am showing. This is the first wave. Can you see? This is the first wave. This is the second wave. This is the third wave. This is the fourth wave. This is the fifth wave. So 1, 2, 3, 4 and 5. So that means the principal quantum number will be 5. Principal quantum number will be 5. As simple as that. So very, very important result which comes out is the circumference. The circumference of the orbit is the principal quantum number multiplied by lambda. That lambda is basically your h by p, which is your de Broglie wavelength, which is your de Broglie's wavelength of the electron. Very, very important result which you must know. All these things are important. I cannot block everything, or else I'll keep blocking the entire board only. Think of this entire board only is blocked. Very, very important. Is that clear, everybody? How many of you knew this from before? If you knew this from before, very good. If you didn't know, you learned a new thing. Last thing, in Bohr's model, that's why I said Bohr's model is very, very important. An electron can jump higher or lower, to lower orbits by, if it is to jump higher, that means it will absorb, by absorbing. If it has to come lower, that means it will emit by absorbing or emitting photons, not photons, actually a photon of the energy difference, of the orbits. Each orbit is of different energy level. So there will be some energy difference between the orbits. So that energy difference is directly used. For calculation of that photon's wavelength or frequency. So say for example, this is one energy level, this is one energy level. This is energy V1, this is energy E2. This is higher energy orbit, this is a lower energy orbit. So if it so happens that an electron jumps lower, it gets de-excited. This is de-excited. It's de-excited. Then you will see that a photon is going to be emitted. And the same thing, if the electron jumps up to a higher orbit, that means it gets excited. That would have happened because there is a photon is absorbed. A photon is basically absorbed. This is what would have happened. And please remember, 2 photons can never be absorbed. 3 photons or 5 photons cannot be emitted. Exactly 1 photon is involved in every transition. No matter from where to where, if it has absorbed, it will be exactly 1. If it jumps in stages, like from here to here, then from here to here, for each stage, one photon will be involved. But for direct jump from 1 to 2, 1 to 3, 1 to 4, wherever, exactly 1 photon is involved. Please remember this in mind. Okay, and I can then say that the energy difference between the orbit is the energy of the photon, and that energy of the photon I can write it as hf, or I can also write it as hc by lambda. In fact, later on you will see that this energy difference can be actually calculated. So it will be higher energy, which is E2, minus lower energy. You can do all the calculations, and then finally you see 1 by lambda. Take that hc also below somewhere over here. You rearrange the equation. You get that as rz square 1 by n1 square minus 1 by n2 square. This is very important equation. This tells you the wavelength of the photon emitted or absorbed, that is RZ square. What is Z? Atomic number. What is N1, N2? Those are the principal quantum numbers of the shells where the transition occurred. It's the principal quantum number of the shells where the transition occurred. This is the important formula, guys. Keep this in mind. What is this R, you might say? This R has come because of all these numbers, constants which were involved. This R is your Rydberg constant. Rydberg constant. What is the value of it? It is approximately 1.1 into 10 to the power 7 in SI units. It is 1.1 into 10 to the power 7. Okay. Malvika, I think Deeksha ma'am's setup has just come, yesterday. Most of the wiring is done. I think there is some problem with the UPS or, the power thing. So that's the reason why ma'am has shifted the class on Sunday. Okay, so Deeksha ma'am will be taking the class on Sunday. Don't worry about it. Obviously, if we shift something, it will be for a genuine reason, because ma'am has just got that new setup. Don't worry about it. Cool? Okay. Great. Yes, we'll be having a casual talk session as well very soon. But I know right now is not the time for casual talk. Right now, let's get into gather that momentum, and soon we'll also have a casual talk. So that was that. Next important thing is the radius formula and velocity formula and the energy formula. How many of you, have seen these formulas, and some of you might remember it. So hopefully this will serve like a revision, and those of you who do not know, don't worry. We'll see that now. Now, whenever an electron is revolving in an orbit around a nucleus, this radius, speed, its energy, everything can be calculated using this equation and this equation. Solving them, you get the answers. So the answer comes out to be something like this. The radius comes out as 0.529. You will have over here n square by z. Here you have n square by z, that is in Armstrongs. N is the principal quantum number, z is the atomic number. Yeah. So for hydrogen in ground state, hydrogen z is 1. Ground state, n is again 1. 1 by 1, 1. The radius will be 0.529 Armstrong. So that is also called as Bohr's radius. So for hydrogen at ground state as they call, hydrogen z is 1, ground state n is 1. So the radius, often called as the Bohr's radius, is 0.529 Armstrong. I hope this is clear. If the atom was different or the state energy level was different, n and z values will change accordingly. Similarly, the velocity formula also you should know. What is the velocity proportional to? It is proportional to z and inversely proportional to n. The constant is 2.2 into 10 to the power 6. This is meters per second, SI units. So when z increases, v increases. When n increases, velocity decreases. This is the next formula which you should know. Keep these things in mind. Very good. Next important thing which you should know is energy. So talking about energy, the energy is minus 13.6. Here you have z square by n square, but the answer is not in joules, it's in electron volt. The answer is not in joules, but it is in electron volt. Keep this in mind. So why this minus sign? I will tell you that also. If you start from 0 electron volt means no energy. It is free. It is what? Free. So if an electron has 0 electron volt, it's free. It's not held or thrown, not moving. It's free completely. If the electron has positive energy, 2 electron volt, 5 electron volt, 7 electron volt, that means it has, it has more than 0. It has enough energy to overcome all the attractions and all the bonds whatever is possible, and it has excess energy, so it is in motion. It is in motion, it is traveling freely, but also it has kinetic energy associated with it. So it is not held by the atom or the nucleus. It is not just free, it is also in motion. Understand that. So positive energy means it is not held or bound by the nucleus. It is free and in motion. Zero means it is just free but maybe not yet moving. So naturally, negative energy means it is held by the nucleus, it is bound to the atom. That's why sometimes it is also referred to as the binding energy. It is also referred to as binding energy. Even in gravitational chapter, have you seen the formula for the energy of satellites? It's always negative. It's always negative. So that's why you will see anything which is bounded to something, the energy will be negative. Keep that in mind. So you will see the energy levels to be something like this. First they will be close, then the spacing will increase. You should know that the spacing increases. You should know that the spacing increases as you go higher and higher. The spacing between them becomes even less and less. They become very, very crowded over there. They become very, very crowded over there. If you take the example of hydrogen atom, for hydrogen atom, when you take the K shell, that is basically N is equal to 1, then you take the L shell, then you take the M shell, the energies look something like this. This is minus 13.6 electron volt. This is minus 13.6 electron volt. As you go higher, the value will increase. Yes or no? As you go higher, the value will increase. That means it will become less negative. So it will become something like this, minus 3.4 electron volt. Then here it becomes minus 1.52 electron volt. You know? So it keeps on increasing, but it means it becomes less negative. And very easy to remember these numbers. I'll tell you a trick. Do you see 1, 3, unlucky number, 13, unlucky number? So who is unlucky? Hydrogen. Why unlucky? We don't know, but it says bad luck. So 13, unlucky hydrogen. 1 on the top, 3 below. 1, 3, 13. 1, 3, 13. Do you see 1.5 to 1 and 3 from here? So 1.13, 13. It's as it is over there. You should keep this in mind. And as you go up, it becomes even small. Keep these things in mind. Talking about kinetic energy. Kinetic energy is the negative of the total energy. Remember, kinetic energy is just half mv square. Similarly, the electrical potential energy U is twice of the total energy. Very, very important. Both these things will help you calculate either the kinetic energy or the potential energy of the electron. Keep these things in mind again. Awesome. Thank you, MD Safin. Next thing which you should know is, if you take different shells, and let's say for example, there is an electron which goes from n is equal to 2, n is equal to 2 to n is equal to 1, or n is equal to 3 to n is equal to 1, or n is equal to 4 to n is equal to 1. So essentially they are jumping from any higher orbit to the first orbit. Doesn't matter from where they jump. This is how they are jumping. Then the photon which comes out is in a peculiar range of wavelengths. It was discovered by a person called Lyman. So that's why they are called as the Lyman series. These lines are called as the Lyman series because it was discovered by the person who observed that with certain elements, and it's in a peculiar range. Then if you transit from any higher shell to this shell, n is equal to 2, any higher shell to n is equal to 2, then the range of the wavelengths is in some other range, and all these transitions again emit photons in a very peculiar range. It was discovered by Balmer. It was discovered by Balmer. That's why it is called Balmer series. Then you have transitions from any higher shell to n is equal to 3. To n is equal to 3. These transitions again emit wavelengths in another particular range discovered by Lyman, Balmer, and you have Paschen. You have Paschen over here. And then after this, you have even more. Obviously, it is endless. So when it goes to 4, when it goes to basically 4, that is called bracket. That is called bracket. If you ever forget the names, just remember 𝐲𝐵𝐴. 𝐲𝐵𝐴. Okay? Remember this name. What will you remember? 𝐲𝐵𝐴. Where is it? Pa. Bappa also, you know, synonymous with Ganpati Bappa. So 𝐲𝐵𝐴. So after this, what you do? You put this in brackets. You put this in brackets. And already you are like sighing. You are like whoosh. So when you emit that sound, when you sigh, what happens? Puff, right? That PFF. So that is that next series, guys. That is P fund. That is P fund. So when you sigh, after this, you make that sound puff, right? You PFF. So P fund. That's how you can remember it. Isn't it easy? Now, 𝐲𝐵𝐴, bracket, and then you sigh. Like, what a trick. You know? Very good. So keep these things in mind. Of course, Lyman, Balmer, Paschen series. Questions come from that. I already given you the formula for the electronic transitions right over here. 1 by lambda Rydberg's constant Z square, 1 by n1 square minus 1 by n2 square. n1, n2 are nothing but the principal quantum numbers from where they transited. You can use that formula for any of these things. If I ask you, out of all these Lyman transitions, which one will be the largest wavelength? Which one will be the largest wavelength? Think about it carefully. Come on. Which transition will be the largest wavelength? 2 to 1, 3 to 1, 4 to 1, 5 to 1? Largest wavelength. Okay. So the logic for that, always remember, delta E is hc by lambda. So if you are looking for largest wavelength, remember you are looking for the smallest energy difference. Smallest energy difference is here. So this will be the largest wavelength. So if you see the light which will come out of that, that will be of largest wavelength. So this will be the largest wavelength. So from 2 to 1 transition, that's your max wavelength. If you go from infinity to 1, obviously the energy difference is very large. So lambda will be very less. So you will see from infinity to 1, the wavelength emitted will be very, very less. So this is from infinity to 1. So this will be the minimum wavelength. And the same thing continues here also. The smallest Balmer wavelength will be from infinity to 2. And the maximum Balmer wavelength will be from n is equal to 3 to n is equal to 2. This is smallest energy gap will have maximum wavelength. Largest energy gap will have smallest wavelength. Keep this in mind. Clear? Yeah. 1 to 2, yes, it won't emit. It will absorb light. Correct. So if I change the arrow marks, right now they are all pointing down. They are all emitting. They are all emitting the light. But if I draw the arrow marks exactly upwards, obviously they will be all absorbing light. So you can call this as emission spectrum. But if I show the arrow marks out, that will become absorption spectrum. One and the same thing numerically. It's just whether it is emitting or absorbing. I think we are good to solve. Oh my God. What is this? The answer already came over here. Can somebody explain why the answer is this? Read the question. When an electron goes from 1 to 2, then the radius becomes, will I teach for 2025? Yes, Akshay, why not? Why will I do partiality for 2025 students? You are also my students. 2024 also are my students. 2024 just needs me urgently now. Just come back to the channel. All these days I was not there, somewhere else. So now I need to take care of them. Their exams are around the corner. I'll be definitely taking care of all of you once their exams are done. Okay? Chalo. Okay. Come on, think about it. Why is the answer quadruple? From 1 to 2, the radius. Remember, radius formula had n square on the top. So if n goes from 1 to 2, that means you are doubling it. You are basically making it 2 times. So if n becomes 2 times, the square becomes how many times? 4 times. So that's why the radius also becomes 4 times. Correct. R proportional to n square. Very good, Luxury Hitler. Very good, AQL. Very good, Mohit. Yes, Fatal Shot. Yes, Kalpana. Very good, Achiever. Very good. Yes, how to complete a chapter in 1.5 hours. Watch it at multiple x speed. That's what I would say. But don't keep a target like that, Sharon. That is a wrong thing to do. You cannot do everything in 1.5 hours. Some chapters will take more time, some chapters will take less. Like modern physics, you can see it's very straightforward. Okay, yes, if you want to go deep, you can take 10 hours also. But now is not the time for 10 hours. If I do a chapter for 10 hours, you will be like, yes sir, teaching in very much detail, yes sir, you are learning everything. But how the things will not be important from the exam point of view. I am not doing right now everything from physics point of view, because if I have to teach you proper physics, if I have to teach you in depth, if I have to teach you all the applications, you know it is going to take a lot of time. You might probably learn a lot, but in the exam it's not going to help you. In the exam, what you need right now is marks. What you need right now is a seat in IIT, a seat in NIT, a seat in a good college. Right now, I know it sounds very vague for a teacher to tell, but you need marks and I'm here to help. That's the harsh truth. Or else if you were there with me for 2 years, 100% we would have had so much fun, we would have done everything, in much more lengths. So, okay, why did I go to the next slide? Anyways, I think you saw the answer. When an electron goes from 1 to 2, then the speed becomes how many times? When the speed becomes how many times? Come on. Yes. Which chapter will come next? Account? I want to see that from you. In the comments after the lecture ends, everybody is going to put the next chapter whichever you want. But obviously it will be high weightage. I have few things in mind. Let me know. Should I do, some high weightage topic like maybe current or ray optics or, something like that, or rotation. Rotation is not that high weightage, but it is important. Yeah. Half, yes. Why is it half? Because we know velocity is inversely proportional to n. So if n becomes 2 times, obviously velocity will become half times. This doubles, this halves. This becomes half, that becomes double. Inversely proportional. Correct. Moving on. N is 1 to 2, then the energy becomes how many times? How many times will the energy become? Come on. Think which formula, ratio, proportion, proportionality you are going to use. Come on, think about it. Which proportionality are you going to use? Think about it, my dear warriors. When an electron transits from 1 to 2, then the energy becomes half, double, 1/4 quadruple. 1/4 times. Sure, pakka, lock kiya jaye. Very good. C for Captain Shreyas. Perfecto. When an electron transits from 1 to 2, then the energy becomes, guys, the energy formula, you can see n square is there below. N square is there below. So if n becomes 2 times, the square becomes how many times? 4 times. But all of this is happening downstairs. So therefore, the energy becomes 1/4 times. Energy becomes 1/4 times. Perfect. Yes, C for NIT Calicut, somebody is saying. Wow, nice. Calicut is a nice place to be near the sea coast, and you get nice Kerala food. Yeah. Okay. The kinetic energy of the ground state electron in ionized helium is, The kinetic energy of the ground state electron in ionized helium is 54.4. Kinetic energy, be careful, and not of hydrogen but of helium. This. Only one of the option is correct. How many of you are from Kerala? Want to see the hashtag Malu gang? Malu gang. Okay. 𝐸𝐶𝐤 is also good. Yes. Shravati, very soon. Don't worry. Yep. So let's have a look. First of all, helium. Helium means Z is equal to 2. Ground state, that means N is equal to 1. So energy will be minus 13.6. Z square by N square. So 2 square by 1 square. Correct? So it will be minus 13.6 multiplied by 4. But this is energy, total. I am not interested in total. I am interested in kinetic energy. Kinetic energy is negative of the total energy. So it is negative of 13.6 multiplied by 4. So negative, positive. 13.6 into 4, obviously 54.4. The largest option over here. Don't even have to break your head. Obviously it will be more than 13.6. Don't sit and calculate in the exam. Only one option is there. If two options are there like that, then you will have to calculate. Yes, A for apple. A for apple. Good evening, Sangam. Is it Sagam? Thank you for all those traffic signal kind of hearts in some different country maybe. Okay. So the de Broglie wavelength of an electron in the second Bohr orbit is the de Broglie. I think I mentioned about de Broglie while I was teaching you Bohr's postulate, especially that angular momentum concept. Yes, Manoj, definitely, but put it up in the comments. See, when you put up the topic in the comments and I see more like on those comments, I will get to know that, okay, this topic, I need to go next. If somebody puts a comment, I'm like, oh, why should I like that comment? Like that comment. Comment on that comment also. Argue also, no problem. But you should have good discussions in the comments. Then I will get to know that, yeah, this is some topic which you guys want. Or else I will go in my flow. So what do you do over here? I just told you sometime back that the de Broglie wavelength, if you multiply it n times, the circumference is n times the de Broglie wavelength. Circumference is 2 pi r, is n times of wavelength. And we have to find the wavelength, okay. So what is r? It is the second orbit. So keep this in mind, it is the second Bohr orbit. So that r will be initial orbit into n square by z, right? So de Broglie wavelength of an electron in the second Bohr orbit. So z is 1 only, z is 1, n is nothing but 2, So this will be r naught into 2 square. So that is basically 4 times of r naught. So the radius will be 4 times of the Bohr's radius or the ground state radius. So that will be 2 pi into 4 r naught is equal to n value I just told you is 2. So 2 into lambda. 2 cancels. So lambda will be 4 pi r naught. 4 pi r naught is C for Captain Shreyas again. So that is the correct answer. Yes, it is not A or B. Many of you made a silly mistake. Yes or no? In many books also they have given wrong answer. I have seen this. I was surprised. What nonsense are they doing? So this is the correct answer for this. Option C. Okay? Or else you'll get negative marks. It's neither pi r naught. Many people forget to write r as 4 r naught. If you forget that, then substituting n as 2 cancel, you will get option A. You might have done this mistake also. Forgot to write r as 4 r naught. Because this is not Bohr's radius. This is a radius in that orbit. So Bohr's radius, if you compare, it is 4 times. So that's the common mistake which many students do. Cool? Very good. So that's why you should attend my classes here. Thank you, Akula. Yes, your Captain Shreyas is here. Thank you so much, Royal. Yep. I will definitely answer you, Royal. Just put up your doubt in the comments. It's quite lengthy to read right now, but definitely put it up in the comments. In the following atoms and molecules, for the transition from 2 to 1, the spectral line is minimum for which? Spectral line wavelength is minimum. From one orbit to another orbit it transits. The wavelength which is there is least for which of the atom? I think you have to use Rydberg's formula, which is RZ square something minus something. Question is clearly telling you, where is it? Minimum, right? So minimum means lambda is less. That means Z is more. Who has the highest Z? Lithium 3, helium 2, deuterium and hydrogen 1, 1. So obviously this should be the correct answer, which is D. Yup, IIT Delhi is the correct answer. Yes, Beluga, I will be showing you the DPP. I will be showing you, the Telegram group link. Everything is there right now in the description box, but don't worry, even after the class, I will be showing this to you. Moving on to the next one, coming up on your screen. In the ionization energy of an electron in a hydrogen atom is this much. The atoms are going to the higher energy levels to emit radiation of 6 wavelengths. The higher energy wavelength is how much? Okay, so think about it. This is ground state, this is higher state, even higher state, even higher state, even higher state, and so on and so forth. So the ionization energy of the electron in the hydrogen atom in its ground state is 13.6. That's standard. We know that. There is no point giving that. The atoms are excited to higher energy level, okay, and it emits 6 wavelengths. So think like this. If I was in this orbit and this is the ground level, the only possible de-excitation that can happen is from 2 to 1. Is from 2 to 1, nothing else. If I was in the third orbit, then I can also go from here to here. And I can also go from here to here. And then from here, I go from here to here. So totally 3 transitions can occur. 3 wavelengths of different amount can occur. If I jump from here to here, if I was in this state, then only 1 wavelength I can emit. If I was in the third orbit, then I can go directly from here to here, or I can go from here to here and then from here to here. So 3 wavelengths can come. If I am in the next orbit, n is equal to 4, I can directly jump from here to here. That is 1 wavelength. I can also jump from here to here and then from here to here. Then from here to here. Or I can also jump from here to here and then from here to here. Do you see 3 new wavelengths have come? So count them 1, 2, 3, 4, 5, 6. 6 wavelengths are coming if I was at n is equal to 4. If I was at n is equal to 4. It is clearly mentioned 6 wavelengths are coming. So what is that highest energy level? That is 4. Hence the answer is option B. Hence the option is answer B. Did you understand? Did you understand this concept? Yep, very good. In fact, there is a formula which I can directly give you also. I just explained this concept to you over here. So the number of wavelengths is given by NC2, where n is the highest energy levels, principal quantum number. So 4 is the highest energy levels principal quantum number. NC2, if you do, you will get how many wavelengths are there. So if you try to do this by 4C2, you are going to get this as 6. 4C2 is going to be 6. Correct. That's the correct one. Alternating current is not very hard. It is easy only. I will definitely help you out very soon. Don't worry. Shall we go to the last part, that is nucleus? Are you ready? Yes, are you ready? It's not very big. It's very short. Let's do this. Everyone, how many friends did you invite today for the lecture? Truly, honestly, answer this. How many of you got, how many friends? If you got no one, then write a legend. Sir, I am a legend, sir. But if you got 1, 2, 3, 4, then you are ultra legends. How many of you got at least 1 or 2 students or 3 students or 10 students, sir? Or sometimes you might be watching it in a class. Once, a student told me from Pondicherry, sir, do you know how we watch your videos? So we put it in the projector and we connect the projector to our laptop and we open YouTube, and all the students in Pondicherry, they watched that live stream together. So sometimes behind one view, there could be even 20 or 40 students who are watching the session live. And hats off to the dedication and hats off to the advancements what the kids do, the hacks which the kids and maybe even the teachers do to watch and learn from the best of the best teachers in the country. Thank you so much. Yeah. This is crazy. Yes. Wow, Luxury Hitler already shared it in the friends group of old and new as well. Yes, laws of motion, Sarita, you can find my old videos in this channel itself. Yashwant, nice to see you over here. Yeah, the class will be over after nucleus. Cool. Chalo, let's start with nucleus then. So, inside a nucleus, you have protons and neutrons, and any element X is basically your element. X is basically your element. The number of protons is usually referred by Z, which is your number of protons. And on the top is A, which is the number of nucleons. Nucleons means protons and neutrons together. If you stay in Bangalore or Bengaluru, then you are called as a Bangalorean. If you stay in Mumbai, you are called as a Mumbaikar, right? Or if you stay in Delhi, you are called as a Delhiite. Same way, if you stay inside the nucleus, you are called as a nucleon. And who stays inside the nucleus? A proton and a neutron. That's the total number of protons and neutrons. So, this number A is Z plus N, where N refers to the number of neutrons. Keep this in mind. Now, in some elements, you will see atomic mass number. This atomic number Z, which is atomic number, is same. Like C12 and C14. What are they called? They are called as isotopes. In some elements, the atomic mass number A is same. Those elements are then called as isobars. That means their top number is same. Okay, it could be anything. Similarly, if N, that is the number of neutrons, if that is same, then they are called as isotones. Keep these things in mind, my dear students. Right. If you talk about a proton, the charge on it is plus E, which is positive 1.6 10 to the power minus 19 coulomb. The mass is 1.673 into 10 to the power minus 27 kg. That's the mass of the proton. Whereas if you talk about the neutron, there is obviously no charge on it. The mass is very much similar to this, only the decimal on the third place will change, 1.675 I guess, yeah, into 10 to the power minus 27 kg. So that mass is almost equal. You can roughly take it as the same. Obviously, it's a neutral particle. It is a chargeless particle. Keep this in mind. Yeah, very good. If you talk about the radius, of the nucleus, is 1.2 femto or fermimeter. This F stands for 10 to the power minus 15. Like you have milli, which is 10 to the power minus 3, micro, which is 10 to the power minus 6, nano, which is 10 to the power minus 9, pico, which is 10 to the power minus 12, femto or Fermi, which is 10 to the power minus 15. So that is the radius of the nucleus. That is the radius of the nucleus. Keep this in mind. One interesting thing which happens is, if you try to find the density of the nucleus, if you find the density of the nucleus, which is the mass of the nucleus, upon the volume of the nucleus, you can substitute everything. You will see that it will be a constant. And when I say it is a constant for all the elements. Oh, and in the previous thing, I missed one thing over here. Let me just write it again. I missed the A over here. My bad. So the R value is 1.2 A raised to 1 by 3 FM. So that is your radius. That A was missing, my bad. So A is basically your number of nucleons, or basically your atomic mass number. So that A will be there. So it is a constant for all the elements, doesn't matter. In fact, you will see A will come on the top, it will get cancelled, top and bottom it will get cancelled. There will be something over here and A, there will be something over here and A. You will see the value of A gets cancelled eventually. So that's why it is a constant and it is independent of the elements. Something which you should be aware of. Now, inside a nucleus, how is it that two protons are staying together? Because these two protons will experience a electric repulsion. There will be a strong electric repulsion. If there is a strong electric repulsion, they should fly off, but still they happen to be inside the nucleus. What is the reason for that? The reason for that is none other than your neutrons. And these neutrons, they form bonds with each other or the neighboring protons, and that force over there is called as the nuclear force. This is a new kind of force. It is not like gravity or electrical force. It is a new kind of force. And this nuclear force has certain characteristic. Like it doesn't depend on the charge or the mass. Or basically the mass. It is very strong for short distances in the order of femtometer. Understand that. In fact, it is stronger than electrical force. That's why it is able to hold the protons together, or else they would have, been thrown out of the nucleus. It's strong for, very, very short distances. Not just that, it doesn't follow inverse square law. That means it is not proportional to 1 by r square. It's not like Gm1 m2 by r square, Kq1 q2 by r square. No, it does not follow all these rules. The force can act between proton, neutron, proton, also. And it depends on the spin of the particles. You should not know other details. Don't worry about it. You don't have formulas. You should just know the theory points over there. Okay. So it's a very strong force for only short distance, does not follow inverse square law, can act between all these things, depends on the spin. So these are some important things about the nuclear force which you should be aware of. Now, you should also know that, for example, if I take two protons and two neutrons and club them together, what will I get? I will get basically a helium nucleus. But the mass here and the mass here will not be the same. If I take the mass of two protons, two neutrons, I weigh it on this side, and when they are clubbed together inside the helium nucleus, I will see that the mass is not the same. In fact, always you will see that the mass of the nucleus is always going to be less than the total mass of the protons and the neutrons. So that difference is called as the mass defect. The difference is called as the mass defect, which is the total mass of protons and neutrons minus the mass of the nucleus. So you might be wondering, okay, so there is some delta M which is called as the mass defect. What happens because of this mass defect? How can mass go wrong? Where did the mass go? That mass converts itself into energy. The mass converts itself into energy. So by Einstein's relationship, which is mass energy equivalence. Second time we are seeing Einstein over here, which was given by Einstein. According to him, if mass is destroyed, energy is created. If mass is created, energy is destroyed. That energy which is created or destroyed is given by the delta M into c square. C is the speed of light. Very famous equation. Okay, this is how energy and mass can be related to each other. Mass destroyed, energy created, mass created, energy destroyed. Very, very important. Now, usually the masses involved inside the nucleus, you can see they are very, very small, 10 to the power minus 27 and all that, right? They are very, very small. So for that, we introduce a new unit. Called as the atomic mass unit, which is 1/12 the mass of carbon 12. 1/12 the mass of carbon 12. So one atomic mass unit comes out to be very close to 1.66 into 10 to the power minus 27 kg. 1 AMU comes out to be 1.66 10 to the power minus 27 kg. So you can say the mass of proton approximately equals mass of neutron approximately, this is not exact, approximately, mass of hydrogen, which is approximately 1 AMU. Approximately. Mass of proton, what does hydrogen have? Only one proton. Approximately equals mass of neutron. Yes, that also we saw over here. This number and this number are very close by. 1.675 and 1.66 is very close numbers. Mass of hydrogen is equal to 1 AMU. Is this clear till this point? Put up a yes in the chat box. Put up a yes in the chat box. Everybody clear till this point? Moving ahead. So if you write this in AMU, usually mass defect is expressed in AMU, then you will get this as 931 multiplied by the mass defect, but this will be in mega electron volt. This is the formula which you should know. So if there was a mass defect over here, some mass was destroyed over here, what will be created? If the mass of the nucleus is less, the constituents are more, so some mass is missing. Mass was destroyed. Who will be created? Energy will be created. Who will be created? Mass is destroyed, energy is created. So that energy which will come out is called as binding energy. This binding energy is going to be liberated. So this binding energy is making sense because these protons and neutrons binded together and this energy was released in that process. Now, what is important is if you calculate something called as binding energy per nucleon. Binding energy is nothing but delta M into 931 mega electron volt. Nucleon, which is protons and neutrons together. So that is atomic mass number. Delta M you know how to calculate, is the difference of the masses, is the difference of the masses of the nucleus and the total mass here. So if you calculate the delta M, multiply by 931, that's binding energy per nucleon, that gives you the stability of the nucleus. Stability of the nucleus. If a nucleus is more stable, then this quantity will be higher. This quantity will be higher. Lesser this value, that is less binding energy per nuclear particle, less energy is released, it's not very stable. So if you happen to draw a graph of the different elements, that is A, which is the different elements, okay, atomic mass number, and here if you write binding energy per nucleon, actually here instead of A it should be Z, my bad, atomic mass number, not atomic mass number, just atomic number. That graph goes up, and then again comes down over here, and it reaches a maximum value for iron. For iron. That means iron is the most stable. Most stable. These people over here, they will be jealous of this guy. These people here will be jealous of this guy because he has more binding energy per nucleon. That means it is the most stable nucleus. Most stable nucleus, correct. So if there is a nucleus here which is very heavy, like uranium, thorium, plutonium, all these nucleus which are very heavy, who is jealous of iron, what will they say? Why am I so heavy? Let me lose some weight. So they will break into small parts. So when they break into small parts to become more stable, that process is called as fission. That process is called as fission. Is that clear? And the exact opposite which happens in the sun, small nuclei. Hey, I am also less mass. Oh, you are also less mass. Hey, even I am less mass. Come, let's meet together. Let's come closer to iron. Let's become more stable. So when they become more stable by combining together, that is your fusion process. Fuse, they come together. That is fusion. The opposite is fission. Happens, right? Very good. So I'm trying to relate this to your normal life. I am trying to keep this as simple to understand as possible. Even if you are seeing this for the first time, that's the reason why you should share this video with as many students as possible, as many batchmates as possible. If you want those same batchmates in your next dream college. If you go alone, will there be any fun in that? You won't love it. You want your bestie, you want your BFF, you want somebody you like in that college. So share this video, okay? Chalo. So that was binding energy per nucleon and all that. So I think now we are good to go to some problems. Let's start with the problems. Last few problems coming up on the screen. If Ra22688 nucleus is there, how many protons, how many neutrons? Straightforward, everybody should spam. Everybody should spam the answer. Come on. Option A, B, C, D. 138 protons, 88 neutrons, 138 neutrons, 88 protons, 226 protons, 88 electrons, 226 neutrons, 138 electrons. Come on, what do you think it is? Beluga has shared it to her. So somebody wants some girl to come in that college. Right now he knows that he can't do anything because JEE is around the corner. So he's thinking ahead in the future. If that girl which I like, she comes to my dream college, then my dream will again become true. So I will share the video with her. Both of us will get similar ranks. Both of us will go to the same college. Long. This is like 5-year planning, 7-year planning. Very good. Kudos. So how many protons, how many neutrons? 138 neutrons, 88 protons. B for, yeah, please. B for Beluga's long-term planning. And right now, B for Beluga. Perfect. So I hope whosoever, Beluga wants to, go with is watching this class. and hopefully both of them get the same rank, same college, same counseling, same branch, maybe. Okay, next. 1 AMU equals to, 1 AMU equals to, I just did this, 1 point, close to 1.67, 10 to the power minus 27 kg. Matrimonial beluga. Oh my god, beluga is the most famous kid right now. He must be on cloud 9. Sir made me famous. Okay, great. Yeah, that was standard value. Very good. Density of the nuclear matter varies with nucleon number A as. Density of the nuclear matter varies with the nucleon number. Density, I just told you that when you divide the mass with volume, A comes, it gets cancelled. Don't bother about all those things right now. Just remember, density remains constant. If density remains constant, it is not dependent only on A. So A raised to 0, A raised to 0 is 1. A raised to 0 is 1. Very good. Beluga, I hope you are not on speaker on the laptop. Okay. Okay. The net force between two nucleons, 1 Fm apart, is F1 if both are protons, F2 if both are neutrons, F3 if one is neutron, one is proton. Now think, who is more, who is less? Who is more, who is less? Come on, come on, come on. Proton, 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 neutron, neutron, neutron. If it is proton, proton, then they will repel each other 100%. So because of electrical repulsion, there will be an electrical repulsion like this. There will be no electrical force between neutral particles or proton and neutron, of course. So that is not there, but nuclear force will be there between all of them. So this will experience a strong nuclear force. This will also experience a strong nuclear force. Remember, nuclear force does not depend on the charge or the mass. So don't think, sir, proton, 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 neutron also same force, sir. Yes, why not? Why not? It does not depend on the charge. Yeah, so keep that in mind. So it's something like this. Now, out of all these three diagrams, in which two diagrams the net force is the same? I think in these two diagrams, I can see the same force. I can see the same force. In this force is slightly cancelled by the electrical force. So I think over here, there is slightly less force in diagram 1. So first one is less, the next two are equal. I think it is C for Captain Shreyas. C for Captain Shreyas. Just check this out. Very good. How many of you understood this? It is a very tricky question. If you solve it by some complex method and some crazy techniques, you will get really confused. So please be careful. Okay, very nice question. Moving on to the next one. Coming up on your screen, we just have few more minutes. I need to end this class very quickly within 5 minutes. Radius is 3.6. Then the radius of this much is how much? Radius depends on atomic mass number. So concentrate your attention on atomic mass number only. And we know radius is directly proportional to A raised to 1 by 3. I gave you the formula. R is 1.2, A raised to 1 by 3 femtometer. So that is what is going to tell me the radius of the second nuclear particle. R2 by R1. R2 is basically related to 125 raised to 1 by 3. R1 is for this guy. So 27 raised to 1 by 3. So this is 5 by 3. So R2 I do not know. R1 is 3.6 is 5 by 3. 3 goes with 3.6. 1.2 times 1.2 into 5 is 6. So 6 femtometer or fermimeter. 6 is option A. Just check this out. Yep, that is correct. You just had to use the proportionality. Understood? Oh, clear? Oh, let's go ahead. Oh, perfect. The binding energy per nucleon of the parent nuclei is E. For the daughter nuclei, daughter means which broke into smaller parts. Parent, big, broke into small nuclei, that is daughter. So whose energy will be more or whose energy will be less? Think about it. Whose energy will be more or whose energy will be less? Yup. Parent broke into daughter 1, daughter 2. If they broke, there was a fission which occurred. They became more stable. That means their binding energy per nucleon is higher. So daughter has higher binding energy per nucleon. That means E2 will be more than E1. That is option C. Very, very good. Congratulations. So I think we have done most of the problems. I will do the remaining problems in the marathon session. There were just 2 problems remaining over here. We will do it in the marathon session, okay? Not now. But for now, keep this in mind. The daily practice problem is uploaded right now in the description box. Also, the test link will be activated on Sunday. So that's why you should join the Telegram channel. I will show this to you right away over here. This is your Vedanthu JEE English channel, your favorite. So as you are watching this particular video and you go down right over here, see, join Vedanthu JEE English Telegram channel. Click on this. View in Telegram. Right now I'm on the desktop, so maybe it will not open up properly. So just join that. That's where you will get it. Click and attend the quiz. This is where you will get your DPP. But you have to create your account by entering your mobile number. It's free of cost, no charges at all. Okay? It's just to ensure that no spam occurs and all of that. So you have to put in little bit of effort. Just enter the phone, or you can continue with Google. OTP will come and directly you will see the test. So make sure you click the link and attend the quiz right over here. This is your DPP. It's not just a PDF. You get the timer, your analysis, everything. All right. So make sure you have also hit the like button over here. Let's make this go up a little bit. I hope after the lecture end it goes to 500 very soon. Okay. And you click on subscribe button. This should look like this. That's where you should be, on the screen, so that you get all the updates and notifications. Cool. Chalo. So now it's time to wind up and put up in the comments WP after the lecture is over. WP in the comments, and next topic as well in the comments, and like those comments, comment on those comments, reply on those comments, have debates, so that I know what topic you want next. I hope you enjoyed the class. Leave the comments in the comment section. Thank you very much. Next class is by Navamita. Take care. Have a great time. God bless you all. Hasta la vista.